so last video I showed you how to take kind of tables of data and use PRComp to create a PCA plot. And the plot, if you remember, I just run that real quick. The plot, if you remember, was pretty ugly and not terribly informative. You don't know what any of these points are and just kind of looks nasty. And so today I'm going to show you just real quick how to use ggplot to make a prettier plot. ggplot has a lot of functionality that plot doesn't have, and just a lot of stuff pre-configured to make your life easier. So we'll get started on that. So first thing we do is library ggplot. ggplot wants data frames. So we got to convert our PCA object, which is a PRComp object, to a data frame. So we're going to do df equals data.frame PCA, and we can't just give it PCA because the conversion, it doesn't know how to do that because the PCA object is actually a combination of lists. So rather than messing with that, let's see here. Messing with that, we'll just do it part by part. So we say df equals data.frame PCA $rotation. And so now if we look at our data frame, here we go. It's just the rotation data now. But now we can add additional features. So we can say data frame $% variance equals the PCA $% go away, robots. Percent variance. And so normally if you're adding columns to a data frame, you want to do something like row names. Sorry, that'll go in the first one, row names, df, and that'll keep them in the same order. But the PCA percent variance is already in the right order and it doesn't have any names to go with it, so that wouldn't work. Tried it before in a video I just canceled, so I'll save you from listening to me bumble about, and just know that this works right now because they're already in the correct order. All right, and then we're going to add another thing. So, well, first of all, let's just plot this thing. So we'll say you create plot objects with ggplot. So we'll say p equals ggplot, our data frame. So if you do that, in order to get the plot to show up, you have to say print and then the plot's name. You'll notice on the right, there's nothing there. So ggplot, we got to tell it what kind of a plot it's going to make. So ggplot df tells it, okay, we're making a plot using this data frame. And then we're going to add something called geometry underscore point or geom point. So this tells it that we're making a scatter plot. Okay, and they'll say, you need to give me X and Y, because unlike plot just grabbed the first two columns and said, okay, this is what he's plotting. ggplot wants us to be a little more specific. So we can go over here and we'd say AES stands for aesthetics. So this is where we put our stuff in. And the nice thing about ggplot is once we've told it that we're using the df data frame, it'll grab all those column headers. And so all we got to do is put the headers in. We don't have to do df $PC1. We can just say PC1, PC2. Okay, now if we go plot this, boom, we've got a plot on the right side here. And it looks so-so. It's about as informative as the standard plot. But now what we're going to do is we're going to add some different things to try and make this a little bit more informative. So if you look at our, let's see here, we'll just say row names. If we look at our row names, there's a couple of different groups here. So all of these are from the MCF7 cell line, so that is not informative at all for this data set. But what is different is the treatment, so whether they were given estrogen, DMSO, or long-term estrogen deprivation, LTED, and also whether they were the D mutant, the Y mutant, or the wild type. And unfortunately, because I had to combine a couple different data sets, some of them are called DMute or D538G. So up here, I just used a whole bunch of my most fanciest code to kind of deconvolute this. So the first thing we're going to do is we're going to grab the treatment, which the nice thing is the treatment is always the last thing with an underscore in front of it. So we can say data frame $ treatment. We're going to make a new column called treatment, and we're going to use the lapply function to get the row names. So we're grabbing the row names from the data frame, and then we're putting them into a function where we run gsub on the row name. And I need to do a whole thing on regular expressions because these are useful, and if you don't know these, you will spend your life trying to, I don't know, put your fist through a computer screen because these just save you a ton of time. But essentially, in regular expressions, period means anything, any character, period, letters, words, periods, characters, numbers, anything. If it's a character of any type, it's represented by a period. And then star means 0 or more. So any number of characters preceding an underscore. And we're going to take that and replace it with nothing for the input string. And so I'll show you what that does. And then that returns a list, and lists are worthless and confuse the data frame, so we unlist it is the last thing we do to it. So now if we look at df $treatment, what you can see here is it took something like, here, let's just grab this name here. We took something like, we'll say name equals that, put it in quotes so it knows it's a string and not a variable. And so we can say gsub, so it's looking for the pattern. So the pattern is any number of characters preceding an underscore, and we're replacing all of those with nothing, and then we give it our string, which is name, and it's going to return LTED. So it basically said, okay, here's an underscore, and here's a bunch of characters in front of it, replace those with nothing. So we got our treatments. Okay, it's a little trickier to get the mutants out, but I did it in a couple different steps. So the first one is I made a column called mutants, and I did essentially what we did there, but I basically replaced MCF7 underscore with nothing. So I stripped out the MCF7. All right, so now if we do df $mutant, here we've got all the mutant names with the MCF7 stripped off the front. Then, now what I did is I said, okay, an underscore followed by anything, delete that out. So basically we're grabbing, since the first item now is now the mutant status and everything after that is worthless, we're going to strip out everything after the mutant name. So there you can see now we've got our mutant status, whether it's a D, wild type, or Y. But the problem is that we've got Y mute and Y it's 537S and D mute and D538G. So I'm just going to run 2 more steps where we use gsub to replace Y mute with the correct status and D mute with the correct one as well. Okay, so now if we look at df $mutant, now we can see we've got correct sets. So if you remember the data frames, this is a thing with levels now. So now we can pass this to ggplot. And so this is one of the fancier things that ggplot does, in my opinion. So we'll say ggplot df The aesthetics, it doesn't really matter where you put them, I don't think. I mean, it might. You can actually do different plots on top of each other, but if you put in the main function, the ggplot function, it'll pass them to all of the geom ones, whereas if you put in, say, geom points, it'll only apply them to the points, which I guess is kind of what we want. So we'll do aesthetics, we'll do PC1, PC2, and then we're going to say color equals treatment. Okay, so what this is going to do, let's see here, print P. Oh, goodness, okay. So now what it did is it went through and got all the different levels in the treatment. So there are three different levels. There's the DMSO, E2, or long-term estrogen deprivation, and it grabbed those and assigned a color to each one. So now if we look at the plot on the right, you can see that they're color-coded based on which sample they are. And we're going to add a size function, so that just goes in the general part, not in the aesthetics part, which is weird to me, but whatever. We'll print it, make those spots a little bit bigger. Okay, so now you can see we've got one group of long-term estrogen deprivation up here and a second one here, and then your DMSO and E2 are mixed in a little bit, which is kind of strange, but I'm not going to knock it. Part of it could be how the mutants are responding. So we can't add another color, but another thing you can do is change the shape of the points. So if we go back to our ggplot here, and then we've got size is equal to color, and then we can say shape equals mutant. And then if we plot this again, now what you'll see is that each mutant type has its own shape. So this makes a little more sense, at least in terms of long-term estrogen deprivation. We've got the wild types up here, the Y537S is here, and the D538Gs down here. And so those are all long-term estrogen, but you can tell which mutant is which. And then still doesn't make a whole lot of sense as to what's going on with the non-long-term estrogen deprivation ones, because you can see you got a pretty even mix with some of these. But what you should see is circles on the left, squares everywhere, and triangles kind of spread out in the line too. But this at least gives you an idea of what's going on. Now what I'm going to show you next is probably pretty stupid. It looks pretty dumb, but I'll show you how to do it. You can, instead of using points, you can do labels. So let's do plus geom label. And it's a little confusing. You gotta tell it which one is the label. See, if we try printing it, it's gonna be like, I don't know where your label is. So we can say label equals row names df. And that's probably wrong. Okay, right. I think it has to go in the aesthetics. I don't remember. Let's see here. All right. So the error says requires geom label requires that. Okay. So remember I said you could put certain aesthetics in the main ggplot function. So that's what I did originally. So PC1, PC2. And what it'll do is it'll actually copy that aesthetic from there into both the geom point and the geom label. Okay, and it also wants the label, like what the name is. So what I did originally. So label equals row names df. Okay. Did I spell it wrong? Yes, that's joys of Jeffrey's spelling abilities. All right. There we go. Now it is successful. So now you can see it has actually labeled everyone with its with its row name. So if you wanted to, what we could do if we wanted to apply our color treatment and everything is we could actually do this over here inside of our ggplot aesthetics. If we add our own little thing here. So we'll give it the color, the treatment, the shapes, and then we'll say label equals row names, df. Now you'll see that it actually applied the color treatment to the labels. And the shapes don't really matter because the labels are on top of them. But one problem that you have is the labels are all on top of each other. So give me 1 second here and I'll see if I can fix that. Okay, so hopefully that pause worked. What it suggests to do is instead of using genome label, use genome label repel. We'll see if this works. Maybe I can't spell. R-E-P-L. Maybe I don't have it installed. Hold on. So it looks like I need to install a package. Repel. All right, let's see if this works. Looks like it worked. So let's see if it works now. Oh, right. Library repel. Please work. Maybe. Whoa. All right, so it sort of worked to an extent. Now you can see that the labels are offset a little bit and are pointing to the thing. One thing we can try and do is reduce the size. It doesn't really work either, but you get the idea that you can do some of these things. This is why I'm going to try and do a video on using Plotly. And Plotly will take care of kind of the last of these issues with overlapping labels. So I'll get to that in another video. Sorry for how long this was. I hope it was informative. If you have more questions, like how to add different things like to the axis titles and stuff, let me know. And I'll see you next time.